The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Welcome to our second webinar of the ADC week from our Graitec ADC webinar series. So let's continue on with our slides. So today we will be talking about a workflow, which is going to be between Advanced Design and Advanced Steel, and as well Advanced Design Connection. So we will show you this workflow on today's webinar. My name is Farshad Purusharg, and I am the local product manager for Graitec products for Canada and US. Okay, so as you probably know, we had like 6 different webinars defined for this week. So we have already presented the first one. As well, my colleague has presented the second one in French. And now today we are going to be talking about the workflow between Advanced Design, Advanced Steel, and Advanced Design Connection. So just to let you know, all of you will be on mute mode during the webinar, but at the end we will have a questions and answer session. So don't hesitate to type in your questions when we are going to end the presentation. Okay, just go to an overview of Advanced Design Connection. So it's the same solution provided by Idea Statica. So to just follow our Graitec line of products, which is mainly Advanced Design, Graitec has rebranded the Idea Statica software, and we are calling it Advanced Design Connection. It is the same software, same tools, and nothing is different. So here are some screenshots of Advanced Design Connection, like the some preliminary results, stretch results, and here we have some local buckling results from Advanced Design Connection. Here we have the code check or standards that we have in the software that you see here. So why to use ADC? I will go through this fast because we have already mentioned it in the other webinar. So fast and simple modeling. The modeling process is very easy in this software. And at my first webinar, I already showed it to you directly how it can be done in Advanced Design Connection. Then there's no limitation for geometry, so you can create any type of geometry very easily, either if it's a complicated or if it's a simple one. You can apply various loading scenarios to your connections in the software. The software is fully nonlinear behavior material-wise, so we can cover elastic and as well plastic range of your connection. And finally, we also do code check or design based on finite element forces in the software. So today I'm going to show you the workflow between Advanced Design, Advanced Steel, and Advanced Design Connection. And it's going to be full geometry and forces. So first of all, we will have our analytical model in Advanced Design, which is the full model containing all of the internal forces, and the model is analyzed. Then we will export this geometry to Advanced Steel, Autodesk Advance Steel. In Autodesk Advance Steel, we will be doing or creating the connection. Then we will export also internal forces from Advanced Design to Advanced Design Connection using a special file format. We will create the connection in Advanced Steel. So this time we will imagine that the connection geometry has been built in Advanced Steel. And then we will export the connection to Advanced Design Connection, just the geometry. And finally, to import our forces from AD, we will import them using the option that we had already here, the internal forces option. And also today, I will be showing to you the stiffness analysis in Advanced Design Connection. It's a kind of special analysis, which we have it in Advanced Design Connection. And as well, I will show you the local buckling analysis in Advanced Design Connection. Okay, let's go on with our workflow today. I will open my Advanced Design model. Okay, I have opened the model in Advanced Design software. So we have all of the internal forces already calculated. I will just open the results. Click OK. Okay, as you see, I have the results here. So what we are going to do is, firstly, I need to export my forces to Advanced Design Connection. So what we can do here is let me just save my model. So let's go to desktop, and I will just save it as webinar. Save. Okay, the model is saved. So now let's first export this geometry to Advanced Steel. For that, you can always go to Beam tab here, go to Graitec, export, click here. And today I will be using the SMLX file type for Advanced Steel. I will just name this as webinar SMLX. Okay, very good. Just save it. You can just name it webinar 1 and on desktop. Okay, the file is generated. So next step is to export my internal forces. So I will just select this connection here to export the internal forces. You can just click here and click on ADC export. Yes. So the connection will be exported. I will just keep the default as they are, but just pay attention. We will have an IdeaCon file generated for us. And this will contain all of our forces, and we will import this IdeaCon file to import our forces inside ADC. So just click next. Okay, now we have the window of the export. So what I'm going to do is I will just change this member as continuous and click next. So here we have the load cases. Click next. And in this case, I will just keep probably one of these simple ones. For example, let's go with just this load combination and click finish. So now the Advanced Design Connection window will be opened. But since we want to do our detailing in Advanced Steel, we can just close this window. Okay, that's it. I will just close it. Just to show you that I have the correct IdeaCon connection file, I can always go to the project folder, which was in my desktop, and it was in webinar, and it was here. So as you see here, I have my forces file, import files ready for me to import it later on in Advanced Design Connection. Okay, now let's go on and import our geometry, which we have created using an SMLX, into Advanced Steel. Okay, I have opened Advanced Steel. Let's import my SMLX file, my geometry from Advanced Design. So I will just create a new file. Let's go with that one. It's okay. So now we have created our file. And using the import tool in Advanced Steel, I will import my SMLX file. So it was on my desktop and the name was webinar1 SMLX. Click on that and click open. Now we are importing our geometry from that SMLX file. Okay, the geometry is imported, as you see here. So now let's go on and design or create our connection in Advanced Steel. So we will go with the same connection. So first of all, let's just select these members, and I will just hide the others, so it's going to be easier for us to work. So let's go in here for Advanced Design, Advanced Steel tool. Here we have a tool to hide the members. There you go. Great. Now the other step is going to be, I will make my column here as a continuous column. So you can just click both of them like that. And here we have a tool, as you see here, to merge beams. Just click there. And there you go. Now let's start to add our connections. Just minimize this here. That's good. So let's create a moment connection first from this beam to this column. So you can go to connection tool in Advanced Steel. And in this case, I will use this type. And we can go for an end plate moment connection, for example, this one. We select the main beam or column, and we select the beam. And we have a connection there. I will just adjust it a bit so we will have a better view. But just to let you know, this is an example. So just to show you how we can create our geometry. So let's go there. So we will keep these as they are. Let's go to bolt holes. Let's go with smaller bolt, for example. Okay, that's good. So we have higher edge distance there. I will just decrease it a bit. Okay, that's good. Now we need to put more bolts probably on top. So vertical bolts. And add some outside bolts. Okay, something like this. Obviously, you have the option here in Advanced Steel to change those values. For example, you can just put 2 inches there and 2 inches here. Okay, this seems like a reasonable design, but as I told you, this is just an example. Okay, so we have this connection here created. Let's add another 2 connections for these 2 secondary beams. So for that, I'm gonna go and use probably a shear plate connection, this one. So select the main object and select the secondary beam. Okay, now I have a shear plate added to this beam here. We can just do some adjustments there. So let's go to the cuts. Can actually add some probe for bottom and top flange if you want. Okay, that's okay. Can go to plates and bolts. And we can go actually to vertical bolts. We can assign middle. Okay. And now I will just decrease number of bolts so we can have a better kind of design. Okay, so something like this, I guess it should be okay. Just as a simple example. Okay, we're gonna be repeating the same process for my other beam. So just close that. Same shear plate, select the column and select the beam. And we'll be doing just the same procedure. So stack cope here, top and bottom. Okay. And we can also go and assign middle to our bolts there. It's good. And for our vertical bolts as well, and just put 2. And let's see and check how it looks here. That's okay. For size of the bolts, we can actually change them to smaller bolts. So for that, you can go there and let's go with 1/2 inches for those. And same thing for the other side. Okay, just go to properties. And for my bolts, I will just go and select this. Okay, great. So I have now a kind of like example connection for you, just to show you the export to ADC from Advanced Steel. Okay, let's say we are happy with this design, and now I'm going to be exporting this connection to Advanced Design Connection. So for that, we have a tool here, or add-on, Idea Statica, and click there, click on Code Check Manager. So a window will be opened, which is the link of Idea Statica between Advanced Steel and ADC. So just to let you know, you can select several connections, which we call it like bulk selection here, and export all of them to ADC. But in this case, because we are just working on one connection, I will just go with one. And now select your connection. First thing is you need to first click on the center of connection. Then we select our members, press enter, and finally we select our components, press enter. Yes, we want the welds as well. Okay, now if I go back to the link here, so you see I have a connection created, and now we can actually open that connection, clicking here in Advanced Connection. Okay, this is the connection. So as you see here, I have the full geometry. So now we have the geometry, which is coming from Advanced Steel. Now we just need to import our forces. And if you remember, we have all of our forces in the IdeaCon file. So to import the forces, you can go to Connection Import, click there. And now I will just go to my IdeaCon file. This is the file. If you remember, we have exported it from Advanced Design. Click and select to open. And there you go. Now you have all of the internal forces as well in your model. So I will just select my member 2 here as my load bearing. So now column is load bearing member. And now we are ready to analyze this connection. So you can just click on calculate. And the analysis is finished. And we have these results here. So you can have other types of results, as you know, like I have already displayed it to you, like in the other webinar. For example, you can see the stresses, which they are not too high, and you can check the mesh and bolt forces. Okay. So in this webinar today, also I want to show you other types of analysis that we have in Advanced Design Connection. So first one is stiffness analysis, which is here. And using this analysis, software can provide you a moment rotation curve of stiffness of the connection. And as well, it can let you know that if you can consider the connection as a fully rigid or a fully hinge or a semi-rigid connection. So which is a very nice tool. Let's go back to my design and let's go and study, for example, this member, the moment connection, to see if it's a solid, rigid, or a hinge connection. So I will just switch my analysis type to stiffness, like that. And then I will just click here on this member, go to design, and I will select this member, which is member 4, as my analyzed member. So now what's going to happen is all of the other members will be supported, and software will try to work on this connection to do the analysis, and it will provide us with moment rotation curve, and as well if this connection, the end plate connection, can be considered as a fully rigid or a hinge connection. So let's click on calculate. Okay, calculation is done. Now I can access my results to see the stiffness curve. You can go to check, and here in the right column, if you go to rotational stiffness, you can just go to this page here. So as you see, this connection has been categorized as a semi-rigid for MY direction. And if I make this curve a bit larger, you can see the curve itself. There you go. So this is the elastic and plastic behavior for this connection. And in this case, software is considering it as a semi-rigid connection, as you see here. And we have all of the related values in this table to study more the behavior of the connection. So this is the type of analysis that we have for stiffness analysis. And as well, we have other types of analysis too in this software that I will just show it to you on this specific connection, which is the local buckling analysis. But as you know, like local buckling analysis is much more controlling for thin wall sections or hollow sections. But let's go back in solid. I will switch my analysis to stress strain. There you go. And I will switch my column to be the load bearing. Okay. And now what we are going to do is we will perform a local buckling analysis as well in this connection. So for that, you can always go to check and drop this menu down and click on stress strain and buckling. So it's going to be an elastic buckling solution based of a finite element model. And software will provide us with several eigenvalues for the buckling behavior. Okay, so analysis is done. Let's go to check. And here we have an extra option or result as buckling. Click there. And as you see here, I have around 6 values, eigenvalues or factors, which is telling me that on which load factor of the applied loads this connection will buckle. So obviously the first one is here, and you can actually check the buckling shape as well. Just click there. And this is the buckling shape, the first one, which is probably happening here in the web of this column. I can activate my deform shape. So there you go. So this is the first buckling shape. Then we have the second one. Just click there. And it's happening here in the bottom flange, this part. And you have the others as well. So these are all mode shapes or buckling mode shapes that can be studied, or it can happen for this connection. But as I mentioned, this local buckling is much more critical when you have thin walled members or hollow sections. Okay, let's go back to our slides. So yeah, as you saw, we talked about this workflow, and also I showed you these analysis types in Advanced Design Connection. Let's go on to the next slide. So just to let you know, beside reselling the software, we can also provide you with demo sessions, as well free trial. We have technical assistance and support in case if you need, and consultancy. We have basic training that it can help you to start using using the software to start your projects. And as well, we have advanced training based on your own projects. So these are also the types of services that Graitec can provide for you. Okay, thanks for your time today. Now we are in a question and answer section. So in case if you have any questions, please type your questions in the chat tool of the GoToWebinar, or you can always email me. You have my email here.
Okay, so thanks for your time again. I'm going through your questions. So I have some questions here. So the first one is regarding the export from Advanced Steel. So the question is, the geometry can be modified beyond the capabilities of the connection macro in Advanced Steel, and will ADC be able to analyze the connection? Yes, actually, how it works is most of the time the export from Advanced Steel to Advanced Design Connection, you will have everything, but probably you may lose some parts, especially for complicated connections. So in that case, the best idea is you can also do some modifications or fixes in ADC directly. So actually the modeling module, like the geometry and manufacturing operations in ADC itself, I can tell it's even can be better than Advanced Steel. So you have more options to change or modify your connection directly in Advanced Design Connection. So in case if you see that some operations from Advanced Steel, they are not coming in perfectly, you can always do some small modifications on the model directly in Advanced Design Connection. Can connections created with individual elements like plates, bolts, welds, and etc. can be analyzed in ADC? Yes. Actually, I guess I showed some examples in my other webinar. So any type of element that actually you can define in the geometry, and software is gonna it will mesh it, and it will be considered in your geometry. The other question is, did we lose the top bottom flange copes when we imported the connection? Yeah, it's possible for some sections that export from Advanced Steel to Odyssey. As I mentioned, probably we can lose some operations, but as I already mentioned, it's very easy to define those copes again in ADC. We have a special operation in ADC for that you can create any type of cope or opening in the sections. Can you tell us how to add forces? Yeah, actually, I also mentioned it in the other webinar. So you have several ways. So first of all, you can do it manually directly in Advanced Design Connection. So we have a table there that you can directly add your forces manually. You can import forces from an Excel spreadsheet in the software. And the other way, as I mentioned, or as I showed in this webinar, is just using that option, which is called import connection, that you can import your internal forces for the connection directly from other software. So today in this webinar, I showed you the import from Advanced Design. But if you have other types of frame analysis software, we have special links to also import your forces from those software. Let's go to the other question. Yeah, I guess I already answered that one. That's okay. Okay, I don't see any more questions. So thanks again for your time. And as you see, like, you have my email there. So if you have any other questions, if you probably want to try the software, you need a trial, or any kind of other technical questions, don't hesitate to contact me. Thank you very much, and have a good afternoon in Europe, or a good day in North America. Thanks.